the South America group, and we have Pettare, Venezuela. We're going to begin with the environment and landscape relations, then go to mobility and flow relations, and then the program relations. But first, this is an arrival city from which predominantly the people come from Asia and Europe to Venezuela, and then to Caracas, the capital, and within there go to Pettare, which is on the eastern suburbs, which there are 41 neighborhoods in which we're depicting, and they are colored here based upon their overall area, with the darkest with the smallest area. The arterial road network is predominantly based upon the geography for the highways around the top northern edge, and it is predominantly a subarterial network city.
So this indexing shows the relationship of the elevation with the city of Pettare. The steep slopes and heavy rains affect this area because it is a clay soil, so the heavy rains and warm environment cause the soils to be susceptible to mudslides. The higher elevation allows for clouds to accumulate and causing a longer rainy season. The road to tree network shows how the development versus the environment. And so you can see that the developed area is more covered with roads and the trees is more dense. This shows the ability to develop more and reach out to those more rural areas. And the flora shows the area where there's ability to expand and develop. The streams and rivers. This indexing shows the rivers how they relate to Pettare's road patterns and neighborhoods. The rivers here are generally affected by the pollution and rainfall of the region. The high density of factories and lack of waste collection contribute to the high pollution levels in the main river. As you can see, this river runs straight through the city.
So, like Ashley said before, the topography is the main factor in deciding the layout and of the development area and the road systems. And here we have a slope risk diagram highlighting the safe areas to build and drive according to slope in blue. And as it gets towards the lighter blue, that's right on the 20-degree edge, which is the minimum or the maximum slope that you can safely build on. And also you cannot drive a car straight up that, which requires a lot of heavy construction in order to develop areas in building and constructing terraces and switchbacks and cap tracks. And this creates a non-directional street network that follows the curvature of the contours of the topography rather than direct routes to program areas. And here we can see the main arterial road systems and a catchment area of 1,000 meters around them, with lines going to slopes under 20 degrees. And as you can see, where you get off on an arterial that doesn't connect to any others, you have a really hard time getting to a buildable slope area. And here we have roads and elevations. So the elevation of the road goes about 1,300 feet in this gradient, and you can see that as the elevation rises, the connectivity of the routes becomes more dispersed and has less intersections and points of connection. And so these are areas lacking infrastructure and development. And here we have the major road intersection intensities. So this is where the intensity of the road connections is the highest, which also correlates to the congestion of the main city and the need to alleviate that congestion. And here we have the intersection intensity of all the road systems. And you see as you go farther east that you lose the connection with the route networks. And so all these, what we can derive from these is that the urban density and development have a direct relationship with the route connectivity, and they have an inverse relationship with the road elevation, topography, slope, grade, and the route accessibility.
Here we have the highway catchment, which shows the areas within 1,000 meters of the main arterial, showing how close you can be to the main road system. Here there's the metro stations compared to the neighborhoods. The blue inner circles shows a 5-minute walk radius to any metro station, and then the outer orange curve shows a 10-minute walk radius. Anywhere outside of there is greater than that. This is the bus stops to neighborhoods. It has the same scale with the blue, with the 5-minute walk radius, and the orange has a 10-minute walk radius. With both of them, you can see that there's a huge deficit in the center of Pettare. This is a parking and roads. With the parking, or public parking areas located along the north edge, along the more developed road. And then the parking compared to the transit stations, with the transit stations highlighted in the orange dots, showing you the 5 to 10 minute drive distance.
Okay, so this is the factory pollution within the neighborhood scale. As you can see, a lot of the factories that are shown are right kind of in the center of Pettare, in this industrial area, a little bit outside of the realms of kind of where we're working. Most of Pettare is polluted by all of these factories, which include industry, textiles, and things of that sort. And this is the water tower proximity. So this is the storage for all the water within Pettare, and they are all both on the outskirts of Pettare themselves, in Caracas, Venezuela. And the reason this can be an issue is the accessibility for specific neighborhoods. And this is the water treatment. So the water treatment, the storage are on either side of Pettare, and then the water treatment are on the other side, on the south side. So the reason why this can be an issue is basically because it can be far away from most of the northern neighborhoods, which are kind of on the coastline of Pettare themselves, and this can allow problems for even potable or drinkable water for any of these neighborhoods on the north side. And then this is the energy proximity within the neighborhoods themselves, and the energy proximity is on the northwest side of Pettare. And the reason why this can be an issue is also because of the accessibility within any of the neighborhoods and their ability to either receive energy or have energy at all, because they are very prone to rolling blackouts. And then these are the energy substations. So the substations are what generates most of the energy, which is also close in proximity of the energy themselves that produces the energy within all of Pettare. And it's outside of even our research, which can obviously cause a lot of problems, receiving blackouts for several days, even 2 weeks. And then this is the agriculture. There's only one node for agriculture that we found within our research, and it's a greenhouse, not necessarily knowing or specified to what they could be producing there. Hopefully it's something that is great need, and if it's not, then that might be an intervention that we want to proceed with.
So we're going to jump into the neighborhood's proximity within walking and driving distances to certain programmatic needs. Here we've got the neighborhoods within the distance of schools. The blue is the closest, and the orange is the furthest away, being a 10-minute walk. We can see that they're concentrated in the northwestern portion of Pettare. Here we see the proximity to police. So they're not actually in Pettare, any of them. So a walking distance to a police station is quite far away, even just for these edge neighborhoods. Here's the hospitals or medical care facilities. Again, here we see the northwestern portion are the closest ones, so anything in the southeastern region would basically be out of luck with regards to medical or healthcare. They'd have to drive. Here we see fire station. I changed the key to driving because the fire trucks or fire personnel would obviously be driving to the locations. Anything, pretty much the vast majority is more than a 10-minute drive, which would be quite disastrous considering the structure of how Pettare buildings are built. They're all on top of each other. So if you wait 10 minutes after a fire starts, the whole neighborhood is going to be on fire. So it has potential to be really disastrous, and that maybe needs to have some sort of intervention, adding fire stations or some sort of facilities there. These are parks or green spaces. Again, they're concentrated in the northwestern portion. Shopping is condensed in the same place as everything else, northwestern. These would be interesting to index with the parking that Will talked about. They're concentrated closely together for obvious reasons. These are markets, like grocery stores. They are outside of Pettare, so pretty much the whole western or eastern portion of Pettare wouldn't have walking access to basic groceries.
So in conclusion, through all this indexing, we have kind of realized that a lot of what is already in Pettare is in the western portion. And so because of this, we chose an easterly location to start thinking about indexing and where we might go on further. This is because the limited access of main roadways for these southern regions, they're really in need of that to get to the marketplaces, the city of Caracas. It will also unite the barrios of East Pettare with its neighboring barrios, and we want to provide opportunity of jobs, closer proximity to daily resources, and just easier accessibility for the people living here in this area. And hopefully that improves